Hi, my name's Tom Hoeffel, and this channel is all about helping students learn chemistry. In this video, we're going to be talking about organic functional groups. If you haven't watched the previous two videos on organic chemistry, I highly recommend that because some of the stuff might look unfamiliar without those two videos ahead of time. So we're going to be talking about alcohols, ketones, aldehydes, carboxylic acids, ethers, and amines. And they do look a little bit different, and they look sometimes a little similar. Okay, so let's talk about some of the similarities that they might have in these groups, and a lot of it deals with oxygen. Okay, in these groups, there's going to be two things that you're going to find out. Okay, you're going to have this carbon chain, and sometimes you're going to see an oxygen that's bonded to a hydrogen, and we call that a hydroxyl group. If we have a carbon that's double bonded to an oxygen somewhere, we're going to call that a carbonyl. Now, depending on their locations within the carbon chain, it might make it a ketone, it might make it an aldehyde or a carboxylic acid. So we really have to look closely at how these are the same and how they are different. Okay, so let's jump in to the alcohol. The alcohol is going to have the hydroxyl group somewhere in the chain. Okay, so, and it can be on the end or it can be in the middle. It doesn't matter. So let's go ahead and say that this group here is going to be called an alcohol. And we got this carbon chain. And somewhere in the middle, we're going to have an OH group. Okay, now if we're naming, we're going to name this from the left-hand side because the side chain's closest to the left. Okay, so 1, 2, 3, 4, 5. The normal name that we would give this is something like pentane, okay? But what we're going to do is we're going to take off the E, okay, and we're going to add OL, which means that it's an alcohol, and of course we have to give it a location, so we're going to call this 2-pentanol. That's kind of what makes this problem an alcohol, okay? Now let's jump in to what a ketone is. The ketone is going to have the carbonyl. So somewhere there's going to be a carbon that's double bonded to the oxygen, okay? And its location is really important, okay? It has to be in the middle somewhere in order to be a ketone. So if I'm going to label this group as ketone, I'm going to do kind of a base structure, just kind of like what I did before, because I want to kind of give you like an apples to apples so you can compare and contrast really easily. And I'm going to put a carbonyl somewhere in the middle. I'm going to put it on the second carbon again. And I want to remind you that there's just one oxygen right here. So 1, 2, 3, 4, 5, just like I had before. So normally we would call that like a pentane. I'm all over the place here. And what we're going to do is we're going to take off the E, just like we did last time. And we're going to end it with ONE and put it on the 2. So we're going to call this 2-pentanone. Okay. Now, if this carbonyl was on this end or this end, it would no longer be a ketone. In order for it to be a ketone, that carbonyl, that carbon double bonded to the oxygen, has to be on one of the carbons in the middle of the chain. Okay. If it was on the end, it would no longer be a ketone, it would be an aldehyde. So the only difference here between a ketone and an aldehyde is the placement of that carbonyl. So let's kind of like make a place for aldehydes, maybe up here. And if we have an aldehyde, okay, if we have our base structure of 5, like what we did before, we're going to put the carbonyl here on the end. Okay, now, if I was in charge of chemistry, which I'm not, okay, but if I was, this is kind of like the structure that I'd have, okay? But I've seen so many textbooks where they come in and they put the hydrogen here. Now, I want to remind you, carbons are at every end or bend unless there's an atomic symbol, okay? So this end, there's a carbon right here. But this end, there's no carbon here, just the atomic symbol hydrogen. Same thing right here. There's no carbon right here, just the atomic symbol hydrogen. So our first carbon is really right here. 1, 2, 3, 4, 5, just like all the others. Why they decide to show this bond to the hydrogen, I don't know, okay? But that's kind of like what I see in a lot of textbooks. If I was in charge, I would just leave it like this, okay? But I kind of see this all over the place, you know, on the internet and in textbooks, okay? So this carbonyl is indeed on the end, so it's an aldehyde. So how do we name it? Okay, we're going to start out with our base word pentane for 5 carbons with single bonds throughout. Remember, this double bond is not part of the main chain, okay? So we take off the ending, okay? And the other two, we added the ending, OL and ONE. For the aldehyde, it's going to be the first 2 letters, okay? So this is going to be pentanal, and it's on the 1, so we're going to call it 1-pentanal. One thing I want to, you know, warn you about is the way you write your A's and your O's, okay? If you're not very clear between your A's and your O's, you might trip up your professor or teacher. They might count it wrong. Like if you write, you know, if this is, I'm doing pentanol and here's my N and then I do something like this, okay, is that an O or is that an A? Okay, so be very, very careful with your handwriting, because if it's OL, you have an alcohol. If it's AL, you have an aldehyde, and they are very different. One has a hydroxyl group, the other one has the carbonyl that's on the very end, okay? Well, how about carboxylic acids? How are carboxylic acids different than the other? Well, the carboxylic acids, okay, they are going to have the hydroxyl group and the carbonyl. They have both, okay? Now, if there's both, and because carbon can only have 4 bonds, this has to happen on the ends as well. So I'm going to add to my notes that this has to happen on the end, okay? So if I'm doing a carboxylic acid, what we're going to do is we're going to have 5 carbons, 1, 2, 3, 4, 5, okay? And on the end, we're going to have the carbonyl and the hydroxyl. So that's not just hydrogen, it's a hydroxyl group. And when they're both on the same carbon, which is carbon number 1, this tells you that you have a carboxylic acid, okay? The way we name this, okay, we'll start out with our name pentane. Same thing before, we're going to take off the E, okay? And we're going to add OIC acid. It's happening on the 1, so we call this 1-pentanoic acid. All right, now these are the 4 that are most challenging for students to differentiate between, because there's OHs everywhere, there's these double bonds to the oxygens everywhere. But for quick review, this hydroxyl could be on any one of these carbons, and if there's only a hydroxyl, that's what makes it an alcohol. And we're going to end it with OL. If we have the carbon double bonded to the oxygen and it's not on the ends, it's somewhere in the middle, that makes it a ketone, and we end it with ONE. If indeed it's on the end, that makes it an aldehyde, and we're going to end it with AL. And if that carbonyl is on the end and we have the hydroxyl group, that makes it a carboxylic acid, and we're going to end it with OIC acid, or I see an acid, okay? It's kind of like the little phrase that I have in class, okay? Now, the other 2, okay, are a little bit easier, okay? So I kind of like, the first 4 are kind of hard because they look similar. The other 2 don't have hydroxyls. They don't have these carbon double bonded to the oxygen carbonyls. They're just different from the other 4. So let's go ahead and take a look at our ether. What an ether is, it's simply a carbon chain that gets interrupted by an oxygen. So something that looks like this, okay? So carbon, 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 no carbon, there's oxygen. No carbon, there's oxygen. Carbon, carbon, okay, as far as where the carbons are located. And the way we name this, when you have a carbon chain that's interrupted by an oxygen, it's just ether, okay? And then we count the number of carbons on both sides. There's 3 here, 1, 2, 3. And we're going to treat that like it's a side chain, so we're going to call it propyl. Okay, there's 2. Okay, so we'll call that ethyl. Okay, remember, put them in alphabetical order. So we're going to call this ethyl propyl ether. Okay, and that's it. That's what an ether is. Okay, it looks very different from all of these. Okay, these all have regular carbon chains. This is a carbon chain that gets interrupted by an oxygen. Okay, and then the last group really looks different than all of them because it has an NH2 somewhere in the group. Okay, so remember, this is going to have an NH2 somewhere in the chain. So let's go ahead and write that NH2. So here's NH2, and then it's just a carbon chain. Okay, and so same structure, just like how we called this an ether. Well, if there's an NH2, that means this is an amine. And same thing, we're going to treat this like a side chain. There's no carbon right here. There's NH2. Carbon, 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 carbon. That's 4 carbons. Our prefix for 4 carbons is going to be but. Side chain, we're going to give it YL. So we'll call this a butylamine. Okay. These are our 6 functional groups. Okay. In my class, we will not add double or triple bonds. I'm not going to do anything that changes the ending 2 different ways, okay, because this is just an introductory class. But we will put side chains off of these in the future. But this lesson is just to differentiate the 6 different functional groups that I've decided to teach in my course, okay. Other courses might add amides or esters in here. Okay, hopefully I pronounced those correctly, but I don't teach those in my AP class. I'm just trying to get my students to be familiar with some different organic compounds because they show up frequently on the AP test. But to be honest with you, you don't need to know any of the organic chemistry to answer some of the AP questions, but they tend to use organic molecules. So my take is, let's just do a 3-day crash course, get familiar with some of these organic compounds so that when you're taking a test, you have a comfort level on that particular test. So if you felt this information was helpful, please smash that like button, subscribe, and comment. Okay, those comments really help the YouTube algorithm get this to other students that might be interested in learning chemistry in a straightforward fashion.